Welcome back. Let's continue with mid-latitude cyclones. Now, as the system moves from west to east, this system brings very cold conditions and much needed rain to parts of southern Africa. But before we continue, let's just quickly look at more characteristics of a system. Now, obviously, the rain that this low pressure system brings to South Africa, it affects the Western Cape region. If we go back to our synoptic chart, it's this region over here. Now, the Western Cape experience Mediterranean climate. Now, what does Mediterranean climate mean? It means they receive their rainfall during the winter. Now, the system moves from west to east, like I explained to you, and as the system moves, now keep this in mind. This system moves from west to east, and as the system moves, it forces warm air to rise. Now, in grade 10, the first time we discussed the different types of rain, you were introduced to frontal rain. Now, believe it or not, grade 12s, that frontal rain that you discussed in grade 10 is mid-latitude cyclones. Now, if we quickly just revise on frontal rain, what basically happens? Frontal rain is when cold air approaches. Okay, now keep in mind, a front separates warm air from cold air. So the air in front of the cold front is going to be warm. Now this is very important. Now this front, a cold front, is the leading edge of cold air. So all the air behind the cold front is going to be cold. Now as you can see, there's a front. It separates the cold air from the warm air. Now in grade 10, you've learned, as this cold air approaches, what does it do with the warm air? It forces the warm air to rise. Because cold air is much heavier and denser than warm air. So what does the cold air do? As it approaches, it pushes all the warm air up. What happens with the warm air? Cool, condense, clouds, and rain. And usually the clouds that we can see over there is cumulonimbus clouds, and we experience rainfall. Now, if we go back, as we can see, this is the type of rainfall that the Western Cape experience during winter. Now, as the system gets older, just go back to your synoptic chart. As you can see, it moves from west to east. The system migrates towards the polar regions and it dissipates. We're going to look at the different stages in a second. Now, in a moment, dissipates means it basically die. Now, if you look at mid-latitude cyclones, they're quite massive low pressure systems. They can range between 1,000 to 300,000 kilometers in diameter. And I mean, a mid-latitude cyclone, if all of South Africa is affected by it. The Western Cape usually experiences rainfall, but during winter over the interior of South Africa, we experience these cold snaps or stints because of the mid-latitude cyclone, because of the cold conditions that this mid-latitude cyclone brings to our interior. Now, our coastline experiences most of the time rain, and our interior just experience the cold temperatures. Now, if we look at this mid-latitude cyclone during the mature stage, very importantly, when we look at the mid-latitude cyclone, this is a cross-section from A to B from a mid-latitude cyclone. From a synoptic point of view, very importantly, a mid-latitude cyclone consists of two fronts. Okay, first of all, a cold front and a warm front. Now, on a synoptic point of view, this is what it will look like. There's the cold front. And attached to it is the warm front. Keep in mind, Gr12s, we only experience the cold front in Southern Africa. Now, you've seen it on E-News, on the Weather Channel. You always see during winter, you see this cold front, usually over South Africa, or moving over South Africa from west to east. Now, it's not a typical, if I can show you what it looks like on TV during the winter. Let's say, for instance, that is South Africa over there, and they show us the weather that's going to be happening over the next past days. We usually see this. Okay, we don't usually see the warm front because it's further down south. Now, it's the cold front conditions that we experience. And like I've mentioned to you before, that's the frontal rain that you learned in grade 10. Now, as you can see, let's just quickly get our terms correct. This is the cold front right there. What is a front? It separates two masses of air. As you can see, there's cold air moving, because remember, this whole system moves from west to east, as you can see over there. Now, as this cold front approaches, the cold front is the leading edge of cold air. And the warm front that you see over there, keep in mind, Gr12s, we do not experience this in South Africa, only the cold front conditions. Now, as you can see over here, as the cold front approaches, as it moves from west to east, what happens with the warm air? Remember, the cold front is the leading edge of cold air. What does it do with the warm air? It forces it to rise. What happens to this warm air? It cools, condenses clouds, and it rains. Okay, the warm front is the leading edge of warm air. So, obviously, if that's the warm air, the warm front, that's warm air over there. And in front of the warm front is cold air. From a synoptic point of view, that is a cross-sectional point of view. This is what it looks like. You've got your cold front, and then you got your warm front. Now, let's 1, 2, and 3. Now, we already established that the cold front is the leading edge of cold air. So what's the air going to be like at 1? It's going to be cold. The warm front is the leading edge of warm air. So what's the air going to be at number 2? Warm. Now keep in mind, the cold front is the leading edge of cold air. What's the air going to be like at number 3? Also cold. Now, again, from a cross-section point of view, there's the cold front, there's the warm front. 1, 2, and 3. If you look over here, what's the air going to be like at 1? Cold, because the cold front is the leading edge of cold air. What's the air going to be like behind the warm front? It's going to be warm. And in front of the warm front, it's going to be cold. Now, like I've mentioned, it's only the cold front that affects South Africa's conditions, weather conditions. Now, it's only the cold front that moves over us. Now, this whole system is almost like cowboy and crooks playing guns and robbers. As the system moves, let's just quickly draw. Let me explain this to you. Let me just Get an open space over here. As the system moves over southern Africa, okay, let's say there's Cape Town, there's Joburg, there's Durban. As the system moves from west to east, remember, we don't see the warm front because it's too far down south. So this system moves from west to east. As the system moves over southern Africa, basically what's happening over here is like cops and robbers. This cold front tries to catch the warm front. This is what it basically wants to do. This cold front wants to catch up with the warm front and displace all this warm air upwards because it's heavier and denser. And that creates the thunderstorm activities that we experience in the Western Cape. And as soon as all this warm air has been uplifted, what's left? Only cold air. If you go back to the weather, now it's a very low pressure. The simple reason why it's a low pressure, if we go back to our previous diagram, it's a low pressure system because look what's happening over here. Air is being forced to rise. Now, in the previous episode, we look at the low pressure. What is the low pressure? It's rising air because of warm conditions, or it's because the air is being forced to rise. In this case, what is it? It's because the air is being forced to rise. So, basically, it's not just smoothly, it's being forced upwards. Look at the steep pressure gradient over here. Secondly, right, it creates cool conditions, very cool conditions. And it creates cumulonimbus clouds. Now, what is cumulonimbus clouds again? Let's just quickly recap. Nimbus means rain. So it creates overcast conditions with rainfall. So if we had to draw a weather station model of, let's say, Cape Town, when the mid-latitude cyclone has passed, is busy passing over, it's definitely going to be overcast conditions. Right, temperature is going to be low because it's cold. 21, let's make it dew point temperature 18, and probably going to experience thunderstorms activity. And the wind direction is going to be northwest, and wind speeds, because the isobars are quite gentle, we're only going to experience gentle winds of 15 knots. Okay, now once that cold front caught up with the warm front, it's known as the occluded stage. Now, like I've mentioned, this cold front is the cop, and the warm front is a robber. So this cold front tries to catch this warm front. And when it does, it's known as the occluded stage. And what it looks like on a synoptic map, it's a mixture of the cold front with the warm front. Because basically what happened, this cold front has caught up with the warm front and forced all the warm air to rise. Okay, remember, there's the cold front, that's the warm front. Now during the occluded stage, these fronts are basically mixed because the cold front caught up with the warm front and all the warm air is displaced upwards. Now, we get two different types of occlusion fronts, a warm front occlusion and a cold front occlusion. After the break, I will quickly explain it to you.